Alrighty, so let's go ahead and review synthetic division one more time as well. Here is an example of a cubic polynomial that we want to divide it by x plus 2. Just few reminders. Number one, you can only use synthetic division with linear functions and nothing else. Okay, and please excuse my horrible handwriting. But this only works with linear divisor. If I were asked to divide by, let's say, x squared plus 2, then I have to use long division. I could not do that with synthetic division. Okay. Reminder number 2 is you need n plus 1 coefficients for, it's supposed to be an r, for nth power polynomial. Okay. Do not miss any coefficients. If you miss a coefficient, you will not be able to complete the synthetic division. For example, here we have a cubic function. That means that our function is to the third power. We need to have 3 plus 1 coefficients. We need to have a total of 4 coefficients. If I were to simply write down 5, 4, and 6, I can easily see that I only have 3 coefficients and I am missing one. The one that is missing is x squared. So I need to have the coefficients in descending order. This is my leading coefficient, 5. Then in front of x squared, even though I don't see it, that is the same as saying I have plus 0 x squared plus 4x plus 6. Okay, so we have to add that 0. The next thing that you do after you write down the coefficients is you need to figure out what is the 0. If you are given synthetic division in this format, you will always take the opposite of. We take the opposite just as a reminder. We take the opposite because if this is a factor, then you would be you will end up with a 0 of -2. So when we complete the synthetic division, we always complete it with our possible 0, which tends to be the opposite of this function that we're dividing by. Now the process follows like this. You take your very first, your leading coefficient, and you simply bring it down as you see it. 5 comes down here as 5. Then you repeat the following process. 5 times -2 gives you -10. You write that -10 up here, and then you add the two numbers together. 0 plus -10 is -10. You repeat the process. -10 times -2 gives you 20, and then you add the two numbers together. That gives me 24. Repeat the process. 24 times -2 is -48. When you add those two together, you get -42. Whenever you are completing synthetic division, this very last number will always be your remainder. The way that we fill in this part in our answer, you always start with 1 power less than your original polynomial. Well, we started with a cubic. 1 power less is a quadratic. Now this 5 is the leading coefficient of my quadratic function. I have 5x squared minus 10x plus the constant of 24. And then I have remainder of -42. Now, how do we write that out in WebAssign or as your result of synthetic division? You would say that your answer is the full part of your division, 5x squared minus 10x plus 24, and then we need to add the remainder. That gives me -42 over the divisor of x plus 2. Please note that when we write the final answer, this up here will always be your divisor. And then just another reminder, if we have a remainder of 0, that means that what we started with is actually a real 0 for your polynomial. If you have a remainder, that means that your divisor goes into your original expression exactly that many times, and then you have 42 left over. Which method you use for division will be your choice in most of the problems. However, if the question asks you to complete and show me long division, please make sure you do so. If the question asks you to complete and show me synthetic division, please make sure you do so. On WebAssign, if it asks you to use synthetic division, I really don't see how you got the final answer as long as you do have a correct answer. I have shared in class. I like long division a lot better because it is just like dividing numbers. It is something that I feel comfortable with a lot more than synthetic division. Not just that, synthetic division really has not yet been proven mathematically. It does tend to work. Whoops, don't know what this is doing. It does tend to work, and some students really like it much better. So which method you use is completely up to you. On the final exam as well as midterm, you will see problems with both of those, but really doesn't matter how you get the right answer. Just get it in one of these methods. Okay? If you guys have any questions or need additional review, please, as always,